So today we have a privilege of learning from two amazing NASA subject matter experts that I'm going to introduce to you now. We have with us Dr. Amita Mehta, who is an applied research scientist at NASA Goddard Space Flight Center. She's also a research associate professor at the University of Maryland, Baltimore County, who uses satellite data to better understand weather and climate and hydrologic processes. In addition, Amita develops methodologies and trainings for using remote sensing observations for environmental sustainability and management, something you'll get to learn from her today. She has worked on a number of satellite missions, including NASA's Atmospheric Infrared Sounder and Global Precipitation Measurement Mission, and has used remote sensing to track water quality and map forest cover. For already over 13 years, Amita has been a lead instructor for NASA's Applied Remote Sensing Training, or ARSET program. She received her Master's of Science in Physics from Gujarat University in India and her PhD in Meteorology from Florida State University. So, Dr. Mehta, we are honored to be learning from you today. And another great subject matter expert who's going to start our training today is Dr. Carl Mailings, who is an assistant research scientist at Morgan State University. Also is working at the NASA Goddard Space Flight Center's Global Modeling and Assimilation Office. He works to combine atmospheric chemistry models, satellite retrievals, and surface monitor data to better estimate and forecast air quality to support air quality decision-making globally. So he participates in capacity building through the NASA ARSET program, providing guidance on how to best use NASA data products to support air quality monitoring and management. He obtained his PhD in civil and environmental engineering from Carnegie Mellon University, and he's also worked as a postdoctoral researcher with low-cost air quality sensors until recently. So we're honored to have you here, and without further ado, I'm going to ask Dr. Mehta to share the presentation deck, and Dr. Millings is gonna kick us off with the presentation. But please enjoy, everybody.
All right. So thank you very much for that introduction, and welcome everyone to this session today. So today we're going to be giving you an overview of the ARSET program. That's the NASA Applied Remote Sensing Training Program, and how we help to build capacity in using Earth observations for societal benefit. Next slide, please. So to kick this presentation off, I'll give you an overview of the program and give you a very condensed version of our fundamentals of remote sensing training. And then we'll follow that up with some examples drawn from other trainings which we've given, just to give you a sense of the kinds of information we cover in our various training sessions. And hopefully we'll have some time at the end for Q&A. Next slide, please. So the next slide, please. So the ARSET program, as I said, stands for Applied Remote Sensing Training Program, and our mission is to provide accessible, relevant, and cost-free training on the use of satellite remote sensing data and other NASA data products for societal benefits in a number of application areas. And those application theme areas are agriculture, climate and resilience, disasters, ecological conservation, health and air quality, and water resources. And we should have a poll starting soon, just asking you about what your particular interest is among these different training areas. So while we're waiting for people to fill in that poll, next slide, please. The sort of overall goal or motivation for the ARSET course is to bring people along up this pyramid from awareness of the existence of satellite remote sensing data, which is relevant for their particular applications, through to appreciating what the advantages and also the limitations are of different satellites, to having an appetite for actually using this satellite data to support their work and make their decisions, and finally up through to adoption, so actual use of satellite data by these folks. Next slide, please. So since 2009, we've provided more than 190 different trainings in these different theme areas and reached over 100,000 participants as of last year. They come from 182 countries and more than 17,000 different organizations. And as you can see here from the map of our 2023 participation around the world, we really do reach people in many different countries around the world. So it's really an international program. Next slide, please. So in terms of what the trainings that we provide both online and in-person training courses. All of the in-person courses, as well as most of the online courses, are live instructor-led trainings. We do have some options for asynchronous training for some online courses. All the trainings are provided at no cost to the trainees, and the materials and the recordings of the trainings are made available for free on our website after the conclusion of the training. We train using open source data sets and software to make sure people are able to access these. Our trainings are provided in English. Many trainings are also provided in a second language, usually that's Spanish, although in some cases we have provided trainings in other languages as well. And we offer trainings on a variety of expertise levels. So next slide, please. And those expertise levels range from, at the very bottom, our fundamentals course, which assumes no prior knowledge of remote sensing. I'll be giving a very brief version of that course today. The introductory level courses above that give a general broad overview of the different application themes that we cover. The intermediate courses go into a little bit more detail, talking about specific applications. And then finally, the advanced courses go into a lot of detail about specific NASA data sets and data products and how to use them. Next slide, please. We use a variety of different approaches in these trainings. Most trainings have at least some component of an instructor-led lecture, but we also make heavy use of live demonstrations of data sets and web tools, as well as hands-on exercises, particularly coding-related exercise. You'll see some examples of that later. Immediately following the training, we have a live Q&A session where we answer questions from the audience. We also send out a homework assignment to assess people's the knowledge that they've gained as a result of the training. And then following the training, both immediately after the training as well as 1 year after the training, we send out an evaluation form to our trainees. And that's really to get feedback on what they learned, how they thought of the course, and then especially with the 1 year follow-on to see how they may have increased their use of satellite remote sensing data as a result of what they've learned in the course. Next slide, please. So before we start with the fundamentals, I just want to revisit the poll. So it looks like 82% of people said they were interested in disasters. Climate resilience was a second with about 76% of people, and then a little bit less for the other courses. But I think people were generally interested in a lot of different theme areas. So that's very good to know. So let's start the next poll on your experience with using satellite data. And we can answer that poll while I go through this fundamentals very briefly. So next slide, please. So first we have to ask, what is remote sensing? And basically this is the concept of obtaining information about something from a distance. Probably everyone on this call is familiar with photography. So this is a very commonly used form of remote sensing. But in general, there are many different ways to collect information via remote sensing and many different platforms for remote sensing, not only satellites, which is what we talk about a lot in ARSET, but also ground-based and airborne sensing as well. But some of the key questions to ask when you're thinking about remote sensing, which through the ARSET courses, you'll learn how to answer these questions and how those answers will guide you to specific data sets. But the key questions are, what type of information do you need? How much detail do you need in that information? And how frequently do you need that information? So next slide, please. And when we're talking about remote sensing from the ARSET perspective, we're most commonly talking about remote sensing using the electromagnetic spectrum. So this is the range of radiation encompassing both visible light, infrared, ultraviolet, and so forth. And the key concept here is that different substances reflect and absorb different wavelengths of this spectrum to different degrees. This is known as the spectral signature of the substance. And using that spectral signature, we can infer based on what light wavelengths have and have not been reflected from a given material, we can infer what that material might be. So you can see an example in the diagram here. Materials which are very reflective, like snow and ice, reflect across the broad spectrum of wavelengths. Absorbing things like water absorb, but they don't reflect as much across the wavelengths. And then in between, you have things like soil, different types of vegetation, which reflect different parts of the wavelength to greater or lesser degrees. So those are examples of those spectral signatures. Next slide, please. So with to do remote sensing with the electromagnetic spectrum, we need a source of electromagnetic radiation. And this can come either in the form of passive remote sensing, where we use the sun as our source, or in active remote sensing, where the satellite, the instrument itself is providing a source of radiation. And each of these have their own benefits and drawbacks. But in general, the idea is to use the reflected radiation, the reflected electromagnetic radiation, with either of these two methods, apply a retrieval algorithm, which is a mathematical system for extracting those spectral signatures I talked about, and use that to infer what we call biogeophysical quantities, basically properties of the Earth and the Earth system that we're interested in, for example, temperature, precipitation, soil moisture, and so forth. Next slide, please. So some terminology, I've been using the term satellite. This refers to basically the spacecraft that's orbiting the Earth. Next slide, please. And aboard that satellite, you can have one or more remote sensing sensors or instruments. You can also have the same type of instrument deployed on multiple different satellites. And as the satellite orbits the Earth in a specific flight direction, we refer to the nadir as the point directly below the satellite in its orbital path. And depending on the instrument, it might look to either side or in front or in back of the spacecraft at a different viewing angle, and thereby trace out a swath, so an area of the Earth's surface below the spacecraft, over which the instrument's collecting data as it passes. Next slide, please. As I mentioned, there's different viewing angles, so depending on how the sensor instrument is oriented or if it can tilt, and it can collect information over a wider swath. And in particular, some instruments make use of this change in viewing angle to collect different types of information at different viewing angles. Next slide, please. Another term to be aware of is granule. This is basically the term we use to describe a subset of the data collected as the satellite orbits. And this is really for the purpose of just organizing the data and collecting it into files to share out and to analyze. Next slide, please. So I've been talking about orbits, and it's important to know about orbits because they determine where and when the satellites can make their observations. And there's two general categories of orbits we think about with remote sensing of the Earth. The first is the low Earth orbit. This takes about 90 minutes for one of these orbits to complete. They can be oriented as polar orbits, so passing over the North and South poles, or they can be inclined with respect to that orbit. But in either case, as the satellite is orbiting around the Earth is rotating underneath it, and this usually allows, over the course of multiple orbits, for that swath to track out over all or most of the surface of the Earth. So you get wide global coverage with these low Earth orbits. The limitation is that you're only restricted to observing specific locations at specific times when the satellite's overhead. In contrast with that, we have geostationary orbits. These are farther out, and they're synchronized with the rotation of the Earth, such that the satellite is always above the same point on the Earth's equator. And this allows the satellite to constantly look at the same part of the Earth, so it has the opportunity to make multiple observations over the course of a day. But the limitation there, of course, is that it's always looking at that same portion of the Earth. We'd have to launch many different satellites into different geostationary orbits to get coverage of more of the Earth's surface that way. Next slide, please. Another important property we have to consider is the spatial resolution. So this refers to basically the amount of the ground surface that's represented by a pixel from a satellite imagery. And this determines the level of detail we're able to get. So as you can see in the examples here, if you look at the bottom of those pictures, those little white dots are boats in the ocean. As you can see, as we go from a fine resolution on the left to a coarse resolution on the right, we're no longer able to resolve those small boat objects. So that's generally the limitation and the consideration when we talk about spatial resolution is what can we resolve. Next slide, please. Other important considerations are the spectral and radiometric resolution. So when we're looking at the electromagnetic spectrum, the spectral resolution is the number and the width of the bands of that spectrum, which the instrument is sensitive to. And the radiometric resolution is basically the precision to which we can measure at each of those bands. And speaking generally, the better the spectral and the better the radiometric resolution, the more detailed information we can collect. And with that more detailed information, we can gain more information about different kinds of biogeophysical parameters, which we might be interested in. Next slide, please. I also want to talk briefly about processing levels. So this is how we describe the analysis that goes into the data. So at levels 0 and 1, we're still dealing with the raw radiometric spectral information that we get from the sensors. Next slide, please. And at level 2, we apply those retrieval algorithms to extract those biogeophysical quantities of interest. This is still at the native resolution of the satellite, so it's organized according to the orbit. Next slide, please. And then in level 3, we grid that level 2. Next slide, please. In level 3, we grid those level 2 data into onto a uniform grid in space and time. I'm still seeing the slide for level 2. Yeah, maybe we're having some trouble. Anyway, so the basic idea is in level 3, we regrid the data onto a uniform grid in space and time, and we also apply quality control filters to filter out maybe some of the data that we think might not be as accurate. And then finally, in level 4, we combine satellite data with data from either other satellites or from global models. And that basically helps us fill in those missing data that we may have filtered out earlier, as well as create a complete picture in space and time. And typically for people who are new to satellite remote sensing, we recommend starting off with the level 3 and level 4 data products, since they're uniformly gridded and complete, the quality controls have been applied, and therefore they're easier to work with. I'm still seeing a slide referring to the level 2 data.
Do you see, how about now?
No.
Well, I am moving the slides. I'm sorry.
I guess maybe try stop sharing and start again.
Yeah, and start again.
Yeah. In the meantime, I don't know if we had a poll in terms of your familiarity with working with satellite data products. It looks like 37% of people don't have any prior knowledge about satellite data. So hopefully this fundamentals course, I know it was very brief, but hopefully it was useful for you there. A couple of people, 32%, have used some data products before, and about 11% of people have extensive experience. So that's good to know. All right, so now I can see the right slide. So next slide, please. Okay, great. So just to recap, what are some of the advantages of satellite remote sensing? Basically, the ability to collect information where we wouldn't have ground-based data, the ability to use these satellites to get globally consistent and continuous or nearly continuous monitoring of the Earth's surface, and to combine satellite data together with models to build these complete understandings of the biogeophysical properties we're interested in. Also, especially for NASA data, we make these data freely available, so that's another advantage there. Next slide, please. There are, of course, limitations of satellite data, remote sensing data, which we need to acknowledge. All the properties I talked about, the spectral, the spatial resolution, these are all to a greater or lesser extent competing priorities. So no one satellite instrument is going to max out all of these areas. So we have to make trade-offs in the design. There's also interference from various sources. For example, clouds is a common one that people consider as causing interference or missing data in satellite products. Also, just dealing with the large amounts of data can be difficult, and that's one of the roles that ARSET has, is to orient people, point them towards the tools and resources that can help them analyze this data efficiently. And then finally, even though we validate these data products on a global basis, we also recommend that local validations be done to ensure that the data quality are sufficient for any particular region and particular purpose. So next slide, please. So now we'll go through some examples of trainings in each of our thematic areas, just to give you a sense of what these look like. So starting off with air quality, you can see a couple of examples of some previous trainings. These range from more introductory level trainings in the upper left, an inside look at how NASA measures air pollution. That's an introductory level training, all the way to advanced trainings like in the top, the MODIS to VIIRS transition. So this is talking about two very specific satellite instruments and what the differences are between them. Next slide, please. I'm going to just briefly highlight this training, which was satellite data for air quality, environmental justice, and equity applications. It was a 3-part training where we gave a broad overview of these applications. We dove into a little bit more detail on the air quality application specifically, and we have some demonstrations of how to use the EPA's EJ Screen tool and some Python code to look at satellite data. I'm going to show a clip now from part of that training, which is talking about a different tool, the NASA Worldview tool.
If you haven't worked with satellite data before, I would recommend starting with Worldview. This is an online interactive browser which allows you to easily display many different satellite remote sensing data products. Its main focus is to provide quick access to near real-time satellite data. Some data sets are updated in Worldview within 3 hours of the observation being made. When you open up NASA Worldview, this is what the interface looks like. You'll see to start off with, there's this Welcome to Worldview with some examples of different satellite data sets you can use and look at in Worldview. If you're new to Worldview, I'd encourage you to take a look at some of these examples. I'm going to close out of this right now and just show you what the interface looks like. So you can see in the background here, there's an image of the Earth with some coastline showing up, as you can see here. And the color imagery is from the true color imagery from the Terra Modis instrument, which is you can see here. I can use these buttons here to toggle different layers. So for example, I can turn on the SWOMI NPP VIIRS instrument, and that's what that looks like here. Or the NOAA 20 VIIRS instrument, and that's what that looks like here. So that's these layers on the left-hand slide. I'll go back to those a little bit later. On the bottom, this is the time slider which I can use to scroll backwards and forwards in time. You can see as I scroll back in time, different satellite data is being populated there. I can also use these date selector here to select the date of interest. And then I can pan and zoom using either my mouse controls, clicking and dragging to pan, and using my mouse wheel to zoom, or on this side of the screen, there's buttons related to zooming in and out. Also in the upper corner of the screen here, there's information on the tool, which you can click on there if you want more information. And if you, in particular, if you click this Explore Worldview button, this brings up the introduction again. So just to show you how I might use this tool, I'm going to scroll back to a major air quality event that happened in my area, the northeastern US, on about June 6th, which was when the northeastern part of the United States here was impacted by wildfire smoke from Canada. And you can see in the true color imagery, which is shown here, you can even see this impact right there. So you have the wildfires taking place here, the smoke coming off of those, more wildfires here with the smoke coming out, and you can see the very dense smoke clouds over New York there and the northeastern United States more generally. If we want to look at some of the data products I've discussed today, we would use this Add Layers button to add new layers. So if I click on this, it brings up a menu which categorizes different types of satellite data sets into these different application areas. And you can see air quality is front and center here, which is really nice. Let's look at the aerosol optical depth. So if I pull down this aerosol optical depth menu, you'll see some of the instruments we talked today, the Modis instrument, the VIIRS instrument. I want to go to, let's see, maybe Aqua and Terra Modis combined aerosol optical depth product. So this is one of the data products available. You'll see if you scroll for Aqua particularly, you'll see deep blue algorithm, the dark target algorithm I mentioned. We'll just stick with this combined just to illustrate what this looks like. Let me close out of that. So you can see what this data product looks like here. You can see the aerosol optical depth scale here, and I'm just going to use these options to pick a different color scale just to illustrate what that looks like. So you can see this imagery here, the areas of high aerosol optical depth where there's very dense smoke. And you can even see the interference that the smoke, the densest parts of the smoke are causing with these retrieval algorithms, where we're not even able to retrieve aerosol optical depth in some of these very dense smoke areas. You can also see that clouds are having a similar effect in a lot of areas, blocking the aerosol optical depth information. But even so, we're picking up on some areas of very high aerosol optical depth. Just to illustrate another example of this, I'll bring up another area. I can also bring up, using this menu, the fires and thermal anomalies here. And I'll pick again, the Aqua and Terra Modis fire and thermal anomalies product. I'll check that, close out, and you can see these orange dots which have shown up indicating the locations of fires detected by the satellite. So you can really see how you can use this tool to overlay a lot of different data sets and just get a broad look at what the data is telling us in terms of information about air quality, fires, and various other things that we might want to look at.
All right, thank you. So based on the poll, it looks like more than half of you hadn't been familiar with the Worldview system before, so hopefully that was a good brief introduction to that. So over to Amita for the next slides.
If you haven't worked with satellite data before, I would recommend starting with Worldview. If you haven't worked with satellite data before,
Okay. I have to move past this slide, so let me see.
if you haven't worked with
I
satellite,
think the arrow button right next to the play button might advance the next slide. Right next to the play button on that, on the bottom left corner of the screen there. So there's a left arrow all the way, and then there's a right arrow on the other side of that.
Which
Yeah.
data
Just
before, I
to the
would
left,
recommend
just to the
starting.
left of that button you just clicked.
I see.
If you
That
haven't
little
worked,
arrow.
Okay, I see that. Sorry. Okay, sorry about that. Okay, so just picking up from where Carl left, what we're going to do now is, as you can see here, ARSET trainings, he mentioned there are multiple themes, disasters, ecosystems, water resources, and climate resilience, monitoring and resilience. So what I want to do is go through a list of trainings just so that you have links to those trainings, and then describe a couple of trainings in detail and go through a couple of more tools that help in accessing and analyzing NASA satellite data or even Earth system model data that Carl just mentioned. So starting with what I want to emphasize here is that sometimes you'll have like a thematic training like Carl showed about air quality. Sometimes we have trainings which cut across multiple themes, such as when you think about assessing impact of fires on watersheds, it involves what disasters such as fire, you have air quality and smoke issues there. You also have watershed health issues because vegetation gets burned. If there is rainfall, then runoff that takes that soot and ash in the water and affects water quality. So some of these trainings, as you will see, they range in different, they cut across different themes. And so this one is more like an advanced training that we did, assessing impact of fires on watershed health. There are disaster assessment using synthetic aperture radar. Want to talk, we won't go into sensors in detail, but synthetic aperture radar, which is an active sensor that Carl mentioned, it has advantage that it can see through clouds, which sometimes most of the time, optical data cannot see through smoke or cloud. SAR, as we call it, can see it. So multiple trainings you will find which use SAR. It's day and night sensor, so it doesn't need solar energy reflected. It has its own power source like microwave radiation. It throws on Earth and measures backscatter. And from that information is derived. So you will see multiple trainings, they use SAR along with other sensors that measure like MODIS and WIRS or Landsat satellites. I wanted to continue with the same theme that Carl had for water quality. It's the fire, how it affects watershed health. And these, again, we're focusing on, this is like a typical training would look like. You will see that these are the dates. These are the outlines, what we did. And what it does is it talks about tools which show derived parameters like fire, weather, or it has this being an advanced training, you would actually run a model like soil and water assessment tools. So depending on the level of training, you would have different components to the training. And this is just, I want to continue with the same fire case that Carl showed. This is the fires in Quebec in 2023 in June, which really affected not only that region, but the smoke came all the way down to east coast of US, all the way to Washington, DC and Baltimore area where we are located. And so in this training, we talked about multiple parameters, which are all available from NASA remote sensing or Earth system model data. And here is an example that you can download data we'll talk about the tool later on. Here is a reanalysis model. What we're looking at is skin temperature anomaly over in Quebec. And this is a satellite global precipitation measurement satellite, which provides precipitation. It combined with many international satellite data, it provides a merged precipitation data that is used. And so what you see here are the anomalies, which is departure from long-term mean. So these data sets that we're talking about are really longer than 20 years. So you can have good mean year climatology kind of assessment. And so compared to that, this is May, which is pre-fire. And what you see here is that almost everywhere temperature was warmer than normal and it was drier than normal. And if you look at these shaded area, those were driest and hottest, and that's where most fires actually occurred. So this is pre-fire condition in the watershed that we are checking that indicates that, okay, there may be fire, there's a risk of fire there. And here you will see a clip from my colleague, Sean McCartney. This is another tool you may have used it. It's Google Earth Engine. It's a cloud-based tool where you don't have to actually download data, but you use JavaScript to look at the data, analyze data, and visualize data as shown here. So let's just look at this clip here.
Now, this case study was specific to the Canadian fires burning in the province of Quebec in June of 2023. So again, what we were able to do is look at the standardized precipitation index from April of 2023 to June of 2023 for the area of interest that we defined. And then what we did is we also created soil moisture anomalies, and this was a 30-day window which was built around May 20th, 2023, so that we can assess the soil moisture anomalies within our area of interest. And we can see for a lot of the area that we are interested in, there are negative soil moisture anomaly values. And again, if we turn on the firm's fire detection data on top of these soil moisture anomalies, we should be able to see that, in fact, they do overlap in terms of where the fires are and where the soil moisture anomalies are. There we go. And then we can also turn on the, we can also calculated NDVI anomalies. These are vegetation anomalies for May of 2023. So we can see that just one more layer of assessing soil moisture, precipitation, vegetation health for fire risk.
Okay, so that shows you that one number of parameters in watershed can indicate that there will be fire, and post-fire also you can check what's happening, such as vegetation or soil moisture, how that's changing. Okay, so now just going back to our thematic training, this is water quality trainings. We have a number of water quality trainings starting from very introduction to remote sensing of algal bloom, harmful algal bloom. So each of these trainings would go through which satellites are used, which sensors are used, their characteristics, their strength and limitations, talk about data sets derived from these satellites, and then analyze. And you can see that from introductory all the way to there is a advanced training which was used in Google Earth Engine to derive in situ data as well as satellite data to develop methodology for algal bloom and suspended sediments in inland lakes. That was this was our latest training. So you can here you can just providing example. You can go back and look at these trainings. So just giving you one example of ARSET water quality trainings, NASA has an ocean biology group, and they have ocean color data available for multiple years from many sensors, as we will see next. They also have a tool, it's called CDAS. And we also had a training just focused on CDAS last month. It's a very advanced level tool in the sense that it can start with level 1 data that Carl talked about and helps you convert to level 2 data with your specifications, or you can just analyze level 2 and level 3 data using CDAS. So water quality trainings would focus on how to get data, how to access watercolor data. So that would be chlorophyll A concentration. This is in Caspian Sea, as you can see. This is water temperature. This is in North Sea chlorophyll concentration that you can derive by using CDAS on your own if you like. So these are all the ocean color missions. Now CDAS can handle about 24 missions. They're used for looking at water quality in oceans, in estuaries, and some satellites which have high enough resolutions like Landsat, Sentinel-2, they also can look at inland lakes, which are usually smaller than like ocean or coastal region. Here on the right-hand side, you can see the latest mission that was launched in February. It's called PACE, Plankton Aerosol Cloud and Ocean Ecosystem. So that is a hyperspectral instrument. Again, going back to what Carl mentioned, spectral bands, how narrow and how many there are defines what kind of instrument it is. And PACE is going to be it is an hyperspectral instrument that's going to help in not only looking at just harmful algal bloom, but it also will tell us what kind of phytoplanktons they are, and it will going to help decide that. Again, moving on, we have trainings in ecosystems. Coastal ecosystems, you can see that there are specific spectral indices such as NDVI that Sean just showed. It's a vegetation index. You can have fire index. You can have water index. So different indices are defined here for land. You have hyperspectral data analysis all the way to biodiversity application. Also, there are some airborne imaging instrument. They can provide very specific local information. Those are also taught in one of these thematic areas. This one has been quite popular, monitoring aquatic vegetation with remote sensing that provides all the background, all the strengths and limitations of using satellite data to look at aquatic vegetation. Just to give you an example, this is evaluating ecosystem services with remote sensing. As you will see, several of our trainings, we invite people who are developing tools which may or may not be NASA people. They may be from academia or even sometimes for private companies or organizations. They use NASA data for societal benefits, making decisions, developing tools. So you will see that like this had many guest speakers who developed different types of ecosystem services. This is from Stanford. So once you have a training, this was an advanced level training, you will have demonstration of different tools and what they can do. So again, continuing with the same, you will have this, which data are used for ecosystems. These are all the satellites used to monitor ecosystems. And then there are tools which are shown here. So training will describe everything in detail. There are usually multiple sessions, about 2 to 4 sessions. And so you have overview of about everything. This is again like cross-thematic trainings, agriculture, water resources, and watershed processes. So agriculture training are also very well attended because for food security, of course, it's very important. So you can look at crop monitoring. This uses both SAR and optical data. There is currently a machine learning training going on to look at agriculture output or crops. And just to give you an example quickly, here is crop monitoring using synthetic aperture radar. Again, multiple partners contributed to this, including Agri-Food Canada, European Space Agency, University of Stirling, University of Ljubljana. And so people will come with different expertise, how they have used data, how they have developed their tools, how they validate. So that's the training for you. And it's the same, it says data access, data analysis, these are covered. This was an advanced training, so you get to learn different software. And then this is climate. This is a recent week, a couple of years back, ARSET started doing trainings on climate. And so building climate risk assessment for vulnerability and exposure, that's the latest. Started with introduction to NASA resources for climate change applications. So you have a whole spectrum there you can look at. Just showing one example of when we look at climate change, those of you who use climate change data or who want to use data, they would find like it's like a fire hose. There's so much information out there. How would you pick what data you need, what climate model projections you need? So this training focused on that. This was in 2022. And what it does, it kind of gets you through steps, what kind of applications you want to use. It talks about different scenarios that climate models consider, which application that you are using, and based on that, you would decide what kind of temporal and spatial resolution you need, what kind of post-processing bias correction of the data you need. So this training kind of walks through that. And then, okay, so this really guides for your own region, your application, how would you pick a climate projection? What models to use? Would you combine different models, or do you use just one model? So that you can look at the training for more information. I want to end this this presentation with one training that we did. This was a satellite observations for analyzing natural hazards on small island nations. And it talked about weather conditions such as hurricanes and also trends in sea level rise. And we'll end with one more tool, which is Giovani. If you haven't used it, this is a very useful data access, analysis, and visualization tool. And we'll just look at a case study where you will see how we track Hurricane Maria over
Giovani
Puerto
web
Rico.
tool to search, analyze, visualize, and download data. What we're going to do first is learn to animate rainfall, sea level pressure, and wind speed to monitor Hurricane Maria before it made landfall on Puerto Rico. Then we will also see some other features such as how to get accumulated rainfall or rainfall time series at a specific location. Here we start with iMerge search data. We already know that we want to use rainfall from iMerge, so we can type iMerge here. And as you can see, multiple options are there. For past data, we use iMerge Final, which is a research quality product. But for near real-time current hurricanes, you can use iMerge Early or iMerge Late, which has a few hours of latency. Let's pick iMerge Final and search. You will see a number of options with different temporal resolutions, and the one that we want is the highest spatial resolution and temporal resolution. It's half hourly, 1/10 of a degree in millimeter per hour rainfall rate, and we're going to pick this multi-satellite precipitation estimate with gauge calibration. Once you pick the data, you can pick the analysis option from select plot option here. There are maps, there are other analysis options, and then there are time series. We're going to focus on maps and time series here. First, let's animate rainfall to see how the storm propagated and made landfall over Puerto Rico. Here is the temporal selection. We know that the hurricane was in 2017, September. And the maximum intensity was between 20th and 22nd over Puerto Rico. Let's take 19th to say 23rd of September. And we can animate this data for the region of our interest here. We can select the region, which I already have. If you zoom out, you have this global map, and you can pan in and zoom in to select the region of your interest and draw a box. So let's zoom a little more and get the Puerto Rico, which is this island here, and draw a box. You can draw a box, or you can enter exact latitude, longitude here if you like. Once you have picked the region, you can plot data, and that launches a workflow. So to save the time, I've already created this animation, so you can view that. And here is the animation. You can see that this starts on 19th of September. You can click on this and see, you can speed up if you like. You can see how outer bands are starting to move on Puerto Rico, and then the actual heavy bands and they arrive on 20th of September, just about. It started around 8 or this is like 9:30 p.m. allows you to pick exact half-hourly image to further analyze and see how it affected together with other parameters that we will see. So this is how you can animate any data that you pick from Giovani, and I have done the same. You can go back to the results. You can pick the same domain, but now you can change the data set. You can pick MERA 2, and you can say sea level, pressure, and search. And you can see again there is monthly and hourly data. We want MERA 2, which is this one, hourly, and you can select that and go through the animation. Similarly, you can say wind, say, and search, and you can see that there is surface wind speed. This is monthly, then there is hourly. This is instantaneous, and there is also time average over this hour. Let's look at instantaneous winds, which is what we usually look at to detect or assess how much damage those winds can make. And then again, you can plot data and animate. I have animated both of them, and so let's see. So this is, I've picked a bigger domain here, and as you can see, this is sea level pressure. 996 was the hectopascal was the lowest pressure, and as you can see, the this center moves here. You can again see the time for that, and note down for when exactly the storm approached. And here is the low pressure center that it's just about 7:30 around on 20th of September. Similarly, you can see winds. So these are wind speeds in meters per second, and so highest was here is 30 meters per second. As you can again watch this and see how the storm approached and how winds changed, and then very heavy winds, they appear right on this eastern and southern part again. This is, so 20th was the time when it started affecting, 20th of September, early in the morning and to late in the evening, it affected the island.
So this is just you saw some clips with different tools, how you can without really downloading data, you can select data, analyze, and visualize. There are also trainings which talk about forecast mode. So this was mostly satellite data looking at real time, but there are also models which give you several days to about 10 days to a seasonal, sub-seasonal forecast. So those are available in different trainings as well. So I want to summarize now what we talked about. So ARSET builds capacity in global community to increase use of Earth observations for societal benefits. Helps you better manage, make better decision because it's really a large-scale global data. ARSET trainings, they cover thematic and multi-thematic topics and provide detailed information about satellites and models. The links you can find here, both weather and climate models, and utilize and disseminate open source data, software, and tools. So it's all free. Trainings are also free. And then ARSET conducts program evaluation, as Carl mentioned earlier. We have end of training survey to get feedback of how we can improve. What else would you like to learn? What are the barriers in using this data or tools? So we continually change our training methodology or what we include or how we decide our topics as we go forward. Our team is quite, as you can see, we have experts from Melanie is our program scientist, project scientist, and we have a lot of help in coordination, in editing, and we have subject matter experts in different topics. Not only that, we are from different NASA centers, Goddard, JPL, Marshall Space Flight Center. We also have Ames. And then our translator who translates in Spanish. So it's really a great team to work with. And here is our website that you can visit. You can register for upcoming training. All this material, so all the slides or clips and the presentations are available, recordings on YouTube that you can watch. You can access different thematic areas here. You can have self-paced trainings as well that you can take anytime you like. And you can sign up for our listserv to find out what activities are going on, what new trainings are coming up. And so with that, we'd like to conclude and thank you all for attending this session. And we have a few minutes for question and answer, I think.
Thank you so very much to Amita and Carl for giving us an amazing introduction to our ARSET training program. And again, I very much encourage everybody to check out the website. There's, I think, last time I checked, something like 200 different trainings that are already on the platform. You can sign up for upcoming trainings that are of interest to you and continue to learn from Carl, Amita, and dozens of their colleagues and NASA experts from across the country and the world. So thank you so much. We have just a few minutes for questions. I saw one come in the chat from Adarsh was was interested in learning how to monitor water quality. So if somebody's just trying to learn that, how would you recommend, which training maybe you could recommend he go and explore?
Yeah, I'll just take that question. So if you go to ARSET website and go to water resources, there you will find, I think these slides you can share because all the links are there, Yasha, there are about 6 or 7 trainings which focus on water quality. Starts from the very beginning. Introduction to all the data that are required for water quality monitoring and what kind of issues one works with. If you are working with water quality, you already know that there's atmospheric correction has to be done before you look at the water. That's a big issue. And then some of the trainings, they also talk about that, talk about CDAS tool, which you can use to analyze data. And there is the latest one last year we did for inland lakes, just uses Google Earth Engine because high resolution data like Landsat Sentinel-2 are available. So I would say start with ARSET website, start 2 things, know the fundamental of remote sensing, and then go to the introduction to harmful algal bloom. That's the first one you start with. so you get an overview.
Thank you. I have a question from Sifat. If you can ask your question, and there are a couple in the chat as well.
Thank you.
Sifat, go ahead.
Can I ask in voice?
Yes, please.
Is there any competition of data visualization organized by ARSET?
Say that. I'm sorry. Data visualization.
Competition like NASA run a flagship program like a NASA Space App Challenge. Do you organize such a competition or event for global enthusiasts?
So yeah, ARSET themselves doesn't organize any competitions, but as you mentioned, the Space Apps Challenge would probably be the place to go to for that.
Yeah, and you can definitely use ARSET trainings to get ready for different challenges, and we use them as resources.
Right.
And very quickly, last minute, we have a question about whether any prerequisites are required. Maybe I'll take that. I know that you can take anything, but it's recommended that you, for advanced trainings, that you take some fundamentals trainings first or like previous levels. But again, you can do that in advance of taking part of the trainings. All information is on the website and it's available for free as well.
So for
Carl, go ahead.
For each training, if you go to the page for that training, there will be a list of prerequisites which apply to that training.
So most advanced training would build upon some introductory training. So it always helps you go back and at least do some parts of prerequisites. So then you can follow along the advanced training. I strongly recommend it.
What's maybe final thing about the limitations or regulations on the usage of data?
Carl, I'm just going to, and then you can add. These are all open source data and tools, so you can use them. You can use, so if you want to use slides that we put out or any information that we put out, you can take it from our website and use it also. But, we request that you acknowledge that this came from ARSET training and this training. So you can, as long as you acknowledge, you can use this. We have people using it in classrooms, some professors and some students also using that for the thesis. And then they take some pictures, but they always acknowledge.
Yeah, so I'm sure there's a lot more questions, but we are out of time for this session. But again, we'll be sharing the recording and the links from this session with the rest of the collective community, including those who can join at this very time. And again, huge thank you again to Amita and Carl and the ARSET team that made it possible for this workshop for the community.